Yeah, I think that's pretty good. So I think the day that most of you have been waiting for has finally arrived. Today we're going to do our stable video diffusion video, where we will have our Mistral language model produce a sophisticated text prompt that will get fed into our Flux model to produce a high quality image, and then that image will get fed into stable video diffusion to produce a video from our image. The workflow is a lot simpler than you might expect, and I've even included a tip toward the end that will both increase the duration and the quality of your output videos. So this is going to result in very high quality, nice, smooth output videos with high frame rates. So be sure to stick around to the end for that. Now, I've made this entire process extremely easy. All you have to do is head over to the Patreon page to grab the workflow, and it is embedded in this image of this cool looking cyberpunk girl with sunglasses. And to get this into your Comfy, all you're going to have to do is right click, open a new tab, and then drag this image right into your Comfy. Once you've done that, go into your manager, click install missing custom nodes, restart your Comfy, and you will be set. So now that we have our missing nodes installed, let's run through this workflow and see exactly what it does. On the Flux side of things, everything is almost exactly the same as what it was in the last couple of videos. The only difference is that instead of an image preview node, we have this preview chooser, which will allow us to choose between one of several images. And that's because whenever I'm generating videos, I like to actually set my batch size to 2 at least, or 3 or 4, and then that way I can get several options to choose from before I actually pass it into the stable video diffusion workflow. And other than that, everything else in the Flux workflow is the same. Now on the stable video diffusion side of things, it is actually a pretty small workflow. So we have our output image coming from our preview chooser, and then that gets fed straight into our SVD. And the only thing we're going to need to do to get this running is get our SVD model that our SVD checkpoint loader will need to load. And you will get that over at stability AI/stable video diffusion image to vid xt11. And if you look down here at the bottom, you'll see this is the model file that we're going to need. We will just right click to download, save link as, and then this is going to go into our Comfy models checkpoints. And you can see I've actually already got it saved right there, but that is where you will save it. So let's just take a look at each of these nodes and see what they do. Of course, the checkpoint loader is going to load your SVD model, and then you have this SVD image to vid conditioning node, which will kind of set up the parameters for the type of video that you want to output. So first of all, the width and the height obviously need to match the width and height of the image that you're passing in. The video frames is the number of frames that you want to generate, and from my understanding, the max value that you can put into here would be 25. It may actually let you enter a larger number, but I'm not sure that stable video diffusion can actually generate more than 25 frames. In any case, I typically leave this on 24, and then I leave my frames per second on 12. That way I get exactly 2 seconds of video. Now this motion bucket ID parameter is kind of a measure of how much motion you want to generate in the output video. So basically from the image that you're feeding in, how much do you want it to move? And typically I leave this set at 144. Of course, this is going to be situation dependent. Certain images are just not going to generate that much motion in the output video. So in that case, I will turn it up a little bit more, but typically I don't have to mess with this. And just like with the image generation process, there are no hard and fast rules with how you need to do this. It is a bit of an art that you will have to learn, but the best advice I can give you is that whenever you're producing your image from a text prompt that you want to be fed into your stable video diffusion, you'll want to create an image that emphasizes motion in the image. For example, if you wanted to produce a video of someone riding a motorcycle, you might say in your text prompt for your image generation, create an image of someone riding a motorcycle down the highway with their hair blowing in the wind or something like that. Because if the image that you produce produce is just someone sitting on a motorcycle, there's not going to be much motion in the video that SVD produces. However, if the road is clearly visible in the image and the person's hair is clearly blowing in the wind, then Stable Video Diffusion will be able to tell that there is that motion emphasized in the image, and it will therefore be able to produce more motion in the video. So again, typically I leave my motion bucket at 144 or somewhere right around there, and my goal is really to just produce an image on the Flux side of things that really emphasizes motion. Now, this final parameter here, this augmentation level, is something that I almost always leave at 0. What it does is basically it adds a little bit of randomness to the image that you're feeding in, so that you can possibly, in some situations, generate a little bit more motion. However, in practice, this almost always results in massive blurring or just really weird things happening that you don't want to see in your output video at all. So I almost always leave this augmentation level at 0. And again, the goal is on the image side of things to produce an image that there is just inherent motion that's clearly visible in the image, so that Stable Video Diffusion will be able to produce a good video from it, and in which case you don't really need the augmentation level anyways. Now up here we have this video linear CFG guidance, and this is just like any other CFG parameter in any other node. It is a measure of strictness of how closely you want your output to be to what your input is. So for example, on the Flux side of things, we have our Flux guidance right here, and this will tell our model how closely we want it to adhere to our text prompt. And on the SVD side of things, we have the CFG value that is going to tell our model how closely we want the video to adhere to the input image we're feeding it. And this value is just a minimum CFG that the model needs to maintain. However, as you see in the sampler, we set a CFG anyways, so this value doesn't really play much of a role. I just always leave this at 1, and the only CFG that I change is this CFG on the sampler. And the sampler is just like the other samplers we've seen. Of course, you have a seed, you have your number of steps, and then of course the CFG that we just talked about. You have your choice of sampler, and then your choice of scheduler, and then your denoise value. And all of this is going to work exactly the same as we've seen on other samplers. The choice of sampler and scheduler set to Euler Ancestral and Cross tends to work very well. I've played around with some other samplers and some other schedulers, and really no other combination gives me as good a result as I get with this combination. There may be times where you want to choose a different sampler and scheduler, but a good baseline for you to start with is Euler Ancestral and Cross. And then this last node right here before we get to the video combine is optional really. You could just go straight from the decode to the video combine. The video combine of course just stitches all the frames together and produces the output video, so there's really nothing special going on there. But the real magic is here in this film VFI node, and VFI stands for video frame interpolation. And basically what this is going to do is look at each of your frames, and it's going to find ways to blend those frames together so that the output looks more natural. If you did take this node out and just go from the decode straight to the video combine, all it's going to do is literally just stick all of the frames together, and what you'll see is that looks kind of choppy in most cases. The film VFI finds similarities between frames that are right next to one another and creates a little bit of motion blur so that each frame blends kind of smoothly into the next. And I'll show you an example of this in just a minute whenever we actually generate a video. Now for the parameters that we have here on the film VFI node, of course the checkpoint name is just going to be the model that it uses to generate the extra frames, and that is going to be included in the node, so you don't actually have to go and download that elsewhere. It's already just included whenever you install the node. This clear cache after in frames value here is just a memory optimization parameter, so it doesn't have any effect on the output video at all. This is just for if you start running out of memory whenever you're generating videos, you can set this to a lower number. Basically, it will clear out your memory after a certain number of frames. So for example, if we're generating 24 frames, you can just leave this at 24, and then it will just clear the cache once after it it's gone through all 24 frames. But if you don't have a lot of VRAM and you end up running out of memory as this is running, you could set this to a lower number and it will clear the cache several times as it's processing the video, and this will just help you save memory. It will take a little bit longer, but of course it will help you save memory if you have a lower VRAM card. And this multiplier value is where all the magic occurs. This is going to determine the amount of intermediate frames that the Film VFI node will generate in between your video frames. So we have our SVD, which is going to produce 24 frames of video at 12 frames per second. So that's going to be 2 seconds of video. But what you'll see is the output that we actually get is going to be longer than that. It typically is going to be around 7 or 8 seconds because I tend to leave this on 4. You can increase this if you want and it will produce more intermediate frames, but it really just depends on what your use case is. And then, as I said a moment ago, the video combine is going to actually just stick them together and produce an MP4 or whatever video format you like. You could increase the loop count if you want the video to loop. As with most workflows, I typically leave my save output to false. That way, if I don't like the output, I just won't save it. And then the ones that I do like, I will just right click and save. The pixel format value here, you can choose from one of these two options. If you choose the second option that has the 10 LE at the end, it will save a little bit of data by reducing the file size just slightly. In some cases, theoretically, it could be a slightly lower quality video, so I typically always just leave it on the 420p version. The save metadata option here just burns the metadata into the video itself. This ping pong option here is only relevant if you're going to use the loop count. If you increase the loop count and you set the ping pong to false, then it will just go from start to finish and then loop back to the beginning. If you set the ping pong to true, then basically it will go from start to finish and then from finish back to start, as opposed to just looping back to the start whenever the next loop occurs. So that's all there is to it, and now let's see some examples. Since Flux tends to do very well with the cyberpunk aesthetic, I've chosen to have it generate a close-up photo of a cyberpunk cheeseburger, whatever that is. So let's just run that and see what we get. You can see the output of the Mistral LLM here. In this thought-provoking image, we focus on an intricate high-tech twist on a classic favorite, a cyberpunk-style cheeseburger, blah, blah, blah. You can read the rest if you like. And this is our Cyberpunk Cheeseburger. And again, we have two options to choose from here because we have our batch size set to 2. You can just choose which one you like best. I kind of like this one because it's got this little melty cheese here. So I'm going to click on that, and then you'll just click progress selected image and it will pass this on to the SVD workflow. I don't know if you can hear this. My GPU takes off like a rocket. Quite loud. And just so you can see how long this is taking on my 4090, looks like we're going at roughly 5 seconds per iteration on the SVD sampler. And on the performance over here, we're using up about 15 gigs of the 24 available VRAM. And again, we're also obviously running OBS at the same time. And I'm also running this Samsung Flow, which is doing a, what do they call it, like screen mirroring. So there are some other things eating up some of that GPU, so probably at least maybe 3 gigs or so of that GPU is dedicated to OBS and to Samsung Flow. So I would say probably this SVD is running at about maybe 12 gigs. So if you have a lower end GPU with less VRAM, this will still run just fine at roughly 5 seconds per iteration. And here is our beautiful rotating shot of our Cyberpunk cheeseburger. I think it looks quite good. I don't know that I would eat it. Right, so as I was saying earlier, if you did choose to skip this Film VFI and go straight to a video combine, that would be a little choppy. So if you want to see an example of that, we can just copy this, Control C to copy and Control V to paste, of course. And we will just put this one down here and we will go straight from the decode into that instead of going through the VFI, and we'll run this again, and then that way you'll be able to see what it looks like going through the VFI and then what it looks like if you don't go through the VFI. Getting hungry in this bit. I'm trying to wait for my GPU to settle down. Oh, it's not done yet. There we go. All right, so yeah, there you can see if you do not go through the film VFI first, you will get this output that is a little bit choppy. It's not too bad. Of course, you could change in the SVD settings. If you're generating 24 frames, you could change your frames per second to 24, and then you would have a 24 frame per second video, and it would be smoother, but again, you'd only get 1 second of video. So just zooming in, you can see there's just a little bit of a jump in between each frame, as opposed to the film VFI. It is nice and smooth all the way through. And that is about going to do it for this video. In the next couple of videos, I have kind of a mixture of things coming. On the comfy side of things, we have a video to video. So we're going to be taking something like this and feeding it to a video to video generation model where we can actually extend this out. In some cases, of course, we're going to want to produce videos that are 30 seconds or a minute or maybe longer. So we're going to be taking a look at how to feed a, say, roughly 8 to 10 second video like this into a video to video model and actually output something longer. And the other comfy video that I'm really excited about is Stable Audio Diffusion. So you might have heard that Stable Audio Diffusion has an online tool that you can use, but from what I've heard, it's a little bit slow due to server demand, and you only get, I can't remember, but it's some small duration of a song that it will generate for you, like 20 seconds or something maybe. And so they've released an open source version of their Stable Audio Diffusion model that you can actually run in Comfy. We'll take a look at how to generate full songs and sound effects and voices and whatever else it can produce. And then I'm also going to start putting out build videos for the PC that this is actually running on right now. So if you want to see how to build a high-end PC that will run these types of models very efficiently, or if you just like watching cool PC build videos, I will have those coming soon. And then for the real nerds out there, I have a couple of videos coming where I will actually walk you guys through some code for different types of AI models if you want to really learn how these things work from first principles. And I'm not going to be using PyTorch or TensorFlow or Keras or anything like that. I'm just going to literally write out the code that will implement the math behind these neural networks line by line. That way you can see exactly how they work under the hood. All you really need is a little bit of linear algebra knowledge in terms of like matrix vector operations, but those are pretty simple. It's literally just kind of boils down to multiplication and addition, really. So that's what we got coming. If you guys have anything you guys want to see, put that in the comments below. As always, if you have any questions, put those in the comments. And then of course, if you generate any cool images or videos, either leave links to that stuff in the comments or tag me on X or Instagram. It's the same username on all the platforms, but you can find that in the description as well. And of course, a link to this workflow that you can just drag and drop into your Comfy will be in the description, and a link to the Stability AI page where you can get the Stable Video Diffusion model will also be in the description. If you found this useful, it would be very helpful to me if you would like and subscribe and share this with anyone else you know who might find this useful as well. And I will see you guys in the next one. Take care.